Radhe Radhe Bhayo. Today I am going to solve a new question of Leetcode 980, unique path 3. So what question it's saying? Let me explain the question. Yeah. You are given an m into an integer array grid where grid of ij could be 1 representing the starting square. There is exactly one starting square, means there is a grid in which one box will contain 1 and it can be at only one position. 2 representing the ending square, there is exactly one indication, means one grid will take two value which will occur only once in this grid, which will denote this is an ending square. 0 representing the empty square we can walk over, and some boxes are there, so 0 will represent that we can walk over, means we can go through this grid. Minus 1 representing obstacle that we cannot walk over, and dash minus 1 is a obstacle, means there is a brick which you cannot go in this brick. So return the number of 4 directional walks. You have to return 4 directional walks, means up, down, left, right, from the starting square to the ending square, means you have to start from starting square and reach to the ending square with moving all the 4 directional walks. Means you have to walk all through the grid. Without moving all through the grid, it won't be a possible path. So I will explain the question in better way. So this is a grid given. Let's see. Okay, as the given test case. Yeah, so this is 1 and rest is 0 as in the given square. Wait, let me change the color so that you can explain in better way. Red. Yeah, this is 2 and this is brick. Like you cannot go there. Brick means minus 1. 2 means like you have to reach here only, ending square, and 1 is what? Starting square. Okay, and now what question is saying? You have to reach here only. Okay, you have to reach here to here, so that and the must condition, you have to move all through all the grids which are non-obstacles. So what can be the path? First it will be like this. It will be the first path because you are moving to all the non-obstacles path, right? And what second path can be? See, yes, 1 0 0 0 0 0 0 0 0 0 2 and minus 1. It second path can be this. As you can see, I have traveled through all the non-obstacles path, and then I reach to the ending square. Like this cannot be a path. See, like if this is a grid, 1 0 0 0 0 2 0 brick minus 1 and this, so you can see like you can go from this to this, but as you can see, you did not move to the non-obstacle paths all, so it won't be a possible path. Means what question is saying? You have to go to the ending square with moving, or you can say using all non-obstacles. Means you cannot means any non-obstacle path, you have to move through this. So as the given test case was this, 1 0 0 0 0 0 0 0 0 0 2 minus 1. So as the question is saying, you have to go from this to this with using all the non-obstacle path, and non-obstacles path are denoted by 0. Okay, so what can be the approach? And like all the things are saying you have to go 4 directional, either up, left, right and down. You have to go 4 directional, means you are allowed to go anywhere. Okay, so what text tag I can think of, means at any time I have option to go either left, either right, either up, either down. So this is the option, so I can think of somewhere recursion or backtracking, you can say. Means I will explore all the paths, then I will come, and one thing was also there, you cannot go back to the already moving path. Means I'm going through this, right, my 1 0 0, you cannot move again to this path unless you completed all the path. Okay, so this was the one constraint, you cannot move again to the used path. Means you have to reach to the end, then only in next path you can use those paths which you have used in the previous path. Okay, so we can think of backtracking because we have to explore all options from any grid. Like if you are at any grid, option to go left, right, up, down. Okay, So one thing was also there, you have to also maintain like how many non-obstacles we have moved. As you can see, there are one wait yes one wait wait 1 2 3 4 5 6 7 8 9 10, means there are 10 non-obstacles and one obstacle and one final square. Okay, so when you are reaching here, you have to check whether you have crossed all the non obstacles or not, right? So this is the condition you can check. Like there are many paths you can go from starting to ending, like either go to from this side, either go to this side, either go to this side, but you have to do only once where you have to move all the non obstacle paths, then that only will be the valid path. Okay, so you can calculate how many non obstacle path were there. 0 was non obstacle, and also none is 1 is also a non obstacle because it is neither a 1 neither a 2, so it can also be counted as a non obstacles, and the position where you started from, it will be counted, like it will be a path, na, that's why. So the two things comes in my mind. First I will explore all paths which are going from start to end. Okay, and second path for the you have find the path which is going from starting to ending, but again you have to check whether you have crossed all non-obstacle path or not. If not, then it won't be counted as a valid path. It will be only counted when you crossed all the non-obstacles at least once in that path. Okay, so as in the given diagram grid, see 1 0 0 0 0 0 0 0 0 0 2 and -1. -1 you cannot go because it is a brick, you cannot go through the brick. Okay, so I will start from this, I will go from right side. Okay, and I will mark it as 1, so that next time I see that I cannot move further, I cannot move previous because it is already a visited path. Second path will be this, third will be this, fourth, here I have option to go only down, so I will go down, then I will go left, again down, as I reach to the final. So how many paths you have counted? 1 2 3 4 5 6 7 8 9 10, means I have crossed all the non-obstacle. How many non-obstacles were there? 1 2 3 4 5 6 7 8 9 10, means when you reach to the 2, if the count of non-obstacle is 10, means this is a valid path, means you have crossed all the non-obstacles at least once. And when second path, what it can be, like this is a 1 0 0 0 0 -1 2 0 0. You can go like this, you can go like this. So 1 2 3 4, you reach to the starting to ending, but as you can see, non-obstacle path we have crossed 1 2 3 4 non-obstacle path we have crossed, but how many were there? 1 2 3 4 5 6 7. So is 4 equal to 7? No, means you have somewhere missed that non-obstacle, means you didn't go through that, so it won't be a possible path. So I hope you understand the question, what question wants to say, and how we can approach to this question. Okay, now again, this is a grid, this was a grid, 1 0 0 0 0 0 0 0 0 0 2 and -1, means we have to explore all the paths from starting to ending, and also we have to keep count of how many non-obstacles were there. So first we can keep count of all non-obstacles using a loop, using 2 loops in a grid. Like n is row, how many rows are there? Okay, and m is what, how many columns are there? Okay, so I can go all the loops. Int j is equals to 0, j less than m, and j plus plus. Okay, and if anywhere grid ij is equals to 0, means it was a non-obstacle, you can go through it. So I will, non-obstacle was a variable, I will increment the count. First non-obstacle was what? 1. Why I have written 1? Because 1 will also be counted as a non-obstacle, because when you are starting from 1, it will be counted as a valid path. So already started from 1, and I will count on. And also I have to start from a given index, means there will be a 1, like it can be anywhere, either this or either it can this, but it can be at only once in a grid, but can be anywhere. So we have to also explore where is the starting index. So start x was first -1, and start y index was -1. And if somewhere I got array of ij is equals to 1 means I have got the starting and starting index x, y is equals to y, and start y is equals to j. Okay, now two things I got. First, how many non-obstacles? Okay, and second, starting index, starting x and y coordinates. Okay, now I have to explore all the paths and see whenever I reach to the ending index, I have to check whether the total non-obstacles were covered or not. So I will try to write the code, like backtrack. I have to backtrack all. So array will be a path grid starting I and starting j, and also what, how many non-obstacles were there? Non-obstacles int, sorry, wait, let me erase this. Yeah, wait, set, why this is not working? Sorry, yeah, now it will work. How many non-obstacles were there? And also a count, like I will keep counting whenever I will go through the 0. I will keep the count that I have covered this grid. Okay, now first thing, like from main. Okay, I will write the main later. Okay, so first, like if you are at grid, this grid is, can you access this part? No. Can you access this part? No, you cannot access. So you need to write the case. If anywhere I less than 0, you cannot access, or I greater than row of size, n was row size, or j less than 0, you cannot access, or j greater than equal to column size, or what, you cannot go through the brick, means obstacle path. Okay, so if anywhere you got, you have to return -1. Okay, now what next? Or where, like one thing was also there, when you move from one index to another index, one grid to another grid, you have to make that grid, that you mark that you have used that grid. So what I will do, I will simply mark that grid as -1, means I have moved through this grid. And now at any grid, what I have options, I have to explore all those paths, means or 4 paths were there. So I will call all those paths. First I will call down, and I will, like if I'm going down, so first 0 0 was there. If I'm going down, so index will change as 1 0. So I will increment I plus 1 and j. Okay, and next was, I will count that I will count means count plus 1, means I've counted this path. Another non-obstacle was there. Okay, now again for, now I went down, I will go up. So I -1 j and count plus again I will do count plus 1 and non-obstacle, and again a call of backtrack. I will go left now. So left will be I j -1. So it is 0 0 if I'm going left. So new index will be 0 and -1. So j -1, and also count plus 1, means I am counted the path. I'm counting the path. Next call will be backtrack. I'm going right, j plus 1 and count plus 1 and an obstacle. So, and after doing all the operation, like when I was going from, when I was going from right, I was marking this as used. But when I will come again from this, like after exploring all the paths, when I will come back, I will need to mark this as unvisited. So after exploring all the path, I will mark as again as a non-visited path again, right? And second condition was, so what the base case, like when in the base case I will write, if array of I or j is equals to 2, means you reach the end. After reaching that, you have to check condition. If count was equal to non-obstacle, means if it is equal, means you have explored all the non-obstacle paths. So we'll simply return count. So you will simply add a count result plus. First there was no path, result was 0, so I will simply count result plus, and then I will return. And now I will call this function from the main was there, array was there, some 2D array was there. Okay, some value were there. Starting I got using that loop, start but somewhere 0 x and start y is equals to 0. As I used two loop to find the starting and index, and result was 0. Nothing, means no path for there. So I called the backtracking function using array, starting index 0, x direction, y direction 0, and non-obstacle I have already counted, and again a count, which will count every time. So I hope you understand the question. I hope you understand the solution. Let me summarize it. First, you have to reach to start to end by go 4 directional, means you have to go, you can go anywhere, up, down, left, right. So I thought of backtracking, like I have to explore all the paths. Second, after reaching, you have to also check whether the you have crossed all non-obstacle or not, non-obstacles or not. So I will take a count, and I will keep counting those. Whenever I will cross from 0, I will increment the count, and whenever I will reach to 2, means at end I will check from is the count is equals to non-obstacle, means there are some non-obstacles already in the grid. So I will simply check whether I have crossed all the non-obstacle or not. If I crossed, then I will simply count the result, means I have increment the path as 1, means I got one path. So I summarized the question, like why I got the backtracking intuition. So I hope you understand the question. I will be meeting you in the next video. Till then, take care. Bye bye. Jai Shri Ram.